Hello, Algebra 1B students. This is Mr. Myers. I'm going to go over the problem we were working on in class today. That way I was having some difficulties with getting the algebra tiles to work with. And I figured out what was going on. But to fix it, before I go and explain where the mistake went with that one, let's go ahead and just review a little bit on how to use algebra tiles. First of all, when you have a blue tile like this is an X. Why do I call this an X? An X squared, because I do not know how long or how wide this square is, but I do know that all squares have the same length on all four sides. So if one side we call X, all the other sides we would call X also, and the area of the square is just X squared. Okay, so the next thing I do is I'm going to talk about this. We know this rectangle has a length of X because once again we called the blue squares sides X, and these sides match up perfectly. So that's an X, and this is a 1. And how do I know that's a 1? Because when I come over here and take out the little yellow squares, they fit perfectly on this side, and we are going to call each side of the yellow squares 1. And once again, area of a square is equal to the sides, two of the sides squared, or one side squared. Okay, now that we have that, I'm going to erase this away. And then I'm going to clean up our algebra tiles. And then I'm going to do a problem that only has addition in it, because that's where I went wrong the first time. So if I have X plus 3 times X plus 2, and we use the idea that a rectangle, the area of a rectangle, is one side times the other side. If I use the algebra tiles to fill this in, oops, didn't mean to do that. If I multiplied this binomial by this binomial, I would get the area of this rectangle in terms of X, obviously, because we don't know what X is. So that's what we're trying to illustrate with the algebra tiles. Now, what I've discovered is when you're doing only addition, there's two ways you can do it, and they both work. If you're doing one with subtraction, there's only one way to do it. Well, I'm going to show you the way that we're going to do it. If I make a t-table like this, and I put in this x plus 2 over here, and we have x plus 3 up there. So I'm going to erase this away. That would look like this: x plus 3. And I'll break these apart so there's a little space in between them. And down here, this would be x plus 2. Okay. If I multiply this x times this x, I get an x squared. So what I'm doing is I'm taking the x on the side and the x on the top, and I'm multiplying those two sides together. And when I do that, I get x squared, because x times x is x squared. Well, if I take this x and multiply it by this one, I have 1x. And the same here. 1 times this x gives me 1x, and 1 times this x gives me 1x. And we'll line them up so there we go. And the same thing down here. X times this one gives me, and I'm going to move this down just a little bit so there's a little space in between. And you'll see at the end why I want a little space in between. And the same thing again. This one times this x gives me x. Now I have a 1 times a 1, so that gives me a 1. I have a 1 times a 1, so that gives me 1. I have a 1 times a 1, and this gives me 1. And you can see on this row down here, it's going to be the same thing. It's going to be the exact same thing. So now I have multiplied the top side by the bottom side, and this is my answer. My answer is I have 1x squared. You only see one. I have 5 x's, and I have 6 ones. And that's one way to do it. That probably makes more sense. And when I'm using negative numbers, if any of the x's or the constants are negative, this is the only way it's going to work. Now, there is another way to illustrate this, and I'm going to erase this away. But I'm going to leave the x plus 3 and the x plus 2 up. And then I'm going to tidy up my board, which will get rid of everything. And this is the other way to do it. If I go ahead and I put in an x plus 3, and I'm going to put the third one over here, and you're going to see why in just a second. And I put an x plus 2. Now look at right here. I have an x right here, and a 1 there, and a 1 there. And x plus a 1 is x plus 2. And the same thing over here. I have a 1 here, a 1 here, and a 1 here, and an x. So this is x plus 3 over here. So you can see I have x plus 3 on the top and x plus 2 here. Now all I need to do is fill in. Where I see an x times an x, I put in an x squared. Where I see a 1 times an x, I put in an x. Where I see a 1 times an x, oops, didn't get it all the way over. Same thing here, an x times a 1, I get x there, and then I put in the 2 1s. And look what I have. This is the rectangle. That is the area of x plus 3 times x plus 2. Look it. I have 1, 2, 3, 4, 5 x's. I have 1x squared. And I have 1, 2, 3, 4, 5, 6. 6 ones. I got the same answer both ways. The difference is this one represents the area, and I'm using the x plus 3 and the x plus 2 as parts of my sides. Now, when you get into negative numbers, it gets very confusing because some of the x's and the x squareds, some of the x's are going to be combined with negative x's, and they go away, and it leaves us a gap in here, and it doesn't work so well. So with a negative number, what we need to do is use only the t-chart. And I'm going to do that in our next video. So come back to our next video and you'll see what I'm talking about. Thank you, and I'll see you soon.